The audio didn't work correctly on this when I recorded it, so I'm just going to go ahead and add a little bit of narration. What you're looking at here is the production of salt, which is basically just sodium chloride, and it's made from basically sodium and chlorine gas. Sodium is a metal, and when you add that to chlorine gas, it reacts fairly violently and produces salt. And so this shows the balanced equation for that. And what you see is me balancing that at the right now. Chlorine is always doubled up. It's one of the diatomic molecules we've always mentioned. And then by putting that subscript 2, you'll notice I had to put a couple of coefficients in. And so those coefficients obviously come in play when we do a limiting reactant or any kind of stoichiometry problem. Those coefficients of 2, 1, 2 end up being the ratios of those substances, all right, whenever that reaction takes place. You need 2 sodiums for every chlorine, and then you'll produce 2 salt molecules, 2 NaCl's. And so here what I've got is 16 grams of sodium. I'm going to give you that much. All right, I'm going to give you 2 grams of chlorine gas. So I'm going to limit you to those 2 amounts. And what we're going to do is we're going to see how much sodium chloride will actually be produced with those 2 starting amounts. All right. So this is going to take 2 actual stoichiometry problems, each one 4 steps, because we're going to go from grams of the starting amounts that I gave you all the way through to grams of the sodium chloride. And when both these problems are done, we'll have finished in sodium chloride at the end of the problem, and we should have 2 different amounts made. All right, so what you can see me setting up here is starting amounts in the upper left and how we want to finish at the end, grams of salt. Okay. So now we go ahead and we work through. We know that the first section is changing from grams to moles, so we have to use the periodic table. And when we look at the periodic table, we can go ahead and add the molecular weight of sodium, all right, for every mole of it. So for 1 mole of Na, or 1 mole of sodium, we look at the periodic table and we see that it is, well, it's 23 approximately, 22.99 grams. All right, we're going into moles of the other substance now because we had converted that into moles of sodium. And so here we are. We're going to go from moles of Na, or of sodium, and we're going to go into moles of sodium chloride. And everybody wants to know, how do you know which one goes on top? Well, you want to cancel out of the substance that we used to be in, and you want to go into the substance that we're being asked about, and that's the salt. And so the NaCl goes on top because we want to be in that at the very end. All right. Well, needless to say, those go together 2 to 2. So I guess technically you probably couldn't screw up which side those go on, but if you were canceling out units, it would be wrong if you had them the other way around. All right. We go to the periodic table, figure out what the grams per mole of NaCl is. It's 58.44. All right, already moving quick here into the chlorine, doing the same thing for 1 mole of chlorine. What's the periodic table say for that? 35.45. but chlorine is Cl2, so you'll see I doubled that number to 70.91. Doing our mole to mole step, we want to finish an NaCl so it goes on top. We're trying to get out of chlorine so it goes on the bottom so it can cancel out. And those in the reaction go together, 2 NaCls for every 1 Cl2. And then finally, finish off that last step. Grams per mole of NaCl is 58.44. All right, we've got a couple of answers that we can plug out of our calculators. 16 times 58.44 divided by 22.99. You'll notice I didn't mention those 2's because they end up just canceling. And on the bottom, we're going to take 2 times 2, multiply that by 58.44, and divide that by 70.91. Right? Everything gets multiplied across the top and divided by everything that you have on the bottom. So we plugged out 40.67 grams of sodium chloride if we had 16 grams of sodium. But look at this, the 2 grams of chlorine held us way back. The 2 grams of chlorine was not a lot. It only let us make 3.3 grams of sodium chloride. All right, it's limiting us from making a bunch more. I got a lot of extra sodium left over. All right, so I didn't make 40.67 grams. Although that value came out, I only made the smaller of the 2. The chlorine limited us, and so it's called the limiting reactant. It limited us to only 3.3 grams of product at the very end. All right. Hopefully this helps. I'm going to stop the narration here, and hopefully you can pick up a few things that you might not be picking up in class. Okay?